But, you know, they say better late than never, though, right? So at least we have started the recording. Only thing McKinley has missed so far was I explained that you use one of these two formulas to find the sum of a piece of an arithmetic sequence. There. Anyway, back to the rows of this stadium. What do we know? We know that it's an arithmetic sequence because the number of seats goes up by a set number each time. What we know is that the very first term, meaning the first row, has 8 in it. And since it goes up by 2 each time, we know that the common difference is 2. Now, what we don't know is how many rows we have. But we do know that the last row, however many rows that is, has 24 in it. So it just wants to know how many total seats are there. Well, we could brute force it and go 8 plus 10 plus 12 plus 14 plus 16 plus 18. I mean, this one's not that bad because the distance between 8 and 24 is not that far. But what if it had said like the next one has 170 seats or something? You don't want to brute force it. You don't want to brute force it. Instead, what you want to do is you want to look at the variables you have, a1, d, and an, and use it to find what you don't know. What you don't know is n, the number of rows. So if we look at our two formulas, we know that's a 2. I don't know that. Oh. I don't know this n, but I do know that. I don't know that again. What to do? Oh, wait a minute. That's right. This is the general term. And look what's in the general term. An an we know, an a1 we know, a d we know. So what we could do is we can use the general term of an arithmetic sequence to figure out what n equals. And then once we know what n equals, we could use either one of these formulas to figure out how many seats there are in the section. A sub n is 24. So 24 equals a1, which is 8, plus n minus 1 times 2. And now we solve for n. I'm going to subtract 8. I'm not going to distribute the 2 because I would rather divide by 2. Divide both sides by 2, you get 8 equals n minus 1. Add 1, n is 9. Oh, there's 9 rows. So yeah, could we have brute forced it? We could. Yeah, it's not that bad, is it? We could have brute forced it. What we're going to do, we're going to use the formulas because that's what today is about. And I would rather use this formula just because it's got less going on. So these two things say the same thing, yeah. So S sub 9, meaning the sum of the first 9 rows, is the 9, because that's n. And then in these parentheses, the first term, 8. The last term, 24. And over 2. It is 9 times 16, or 144 seats in that row, or in that section, excuse me. Well, 8 plus 24 is 32. Half of 32 is 16. 9 times 10 is 90. And 9 times 6 is 54. 90 plus 54 is 144. Yes. Okay. Okay. Takes him 2 seconds, he says. Well, I already mentioned them, but yeah. If there is a nth partial sum of arithmetic sequence, you know there's an nth partial sum of a geometric sequence. Completely different formula, though. So if we have a sequence, and we're going to say it's finite, meaning it doesn't go on forever, and it's geometric, then the sum can be found like this. Now remember, any one of these 3 could denote this. This one requires you to know the common ratio. Oh, by the way, the ratio can't be 1. It requires you to know the first term, the common ratio, and the number of terms. You know those three pieces of information, and you could tell me what that partial sum is. So I could give you the numbers, I don't know, like 2 plus 4 plus 8 plus 16 plus 32 plus 64 dot 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 out to plus 1024. What I just have you do, I just had you add up the first 10 powers of 2, and that would be geometric. So it would be 2 times 1 minus 2 to the 10th, which is a big number, it's 1024, divided by 1 minus 2, negative 1. And you would get what those numbers add up to. Okay. I don't need you to understand the formula, I just need you to use it. Cool with that? Yay or nay? Yay! Yay! Okay, moving on. Well, let's use it. Here, I'm telling you, you have a geometric sequence. It starts with the number 4, and then it goes negative 4 thirds, positive 4 ninths, negative 4 over 27, so on and so forth. And we are going to find that, the sum of all of those. We know a sub 1. We could see it. A sub 1 is 4. And we can see how many, or we can find what the common ratio is. Remember, a common ratio is found by taking any term in the sequence, pick one, and divide by the number in front of it, or the number before it. So how about negative 4 thirds divided by 4? I said 4 thirds. Negative 4 thirds divided by 4, but instead of saying divide by 4, I'm going to say times 1/4. Because they mean the same thing. Let these 4's cross cancel, and there you go, common ratio, negative 1/3. Well, shoot, all we need to know now is how many terms there were, right? I mean, you know how many terms there are, and you've got all the information you need to figure out what these things add up to. There's not 10. But why? Because the general term of a geometric sequence is a sub 1 times r to the n minus 1, where n minus 1 equals 10. N minus 1 equals 10 tells you that n is 11. Yeah, because n minus 1 is 10. Oh, yeah. So we know n is 11. Yeah. That's the common ratio. That's this term divided by the one before it. But instead of saying divide by 4, I said times 1/4 because it's easier. Cool. Ready to add these bad boys up? Yes? Because this is the general form for a geometric, correct? The exponent on the common ratio, which was right there, we didn't even need to figure it out. Anyway, the exponent for the common ratio is n minus 1. So n minus 1 is 10. Add 1 to both sides, so I know n is 11. Let us find s sub 11 for this geometric sequence. We have the first term times 1 minus r to the 11th divided by 1 minus negative 1/3. We grab handy dandy calculator. Yeah, you heard it here. And one of the reasons why I like to use the graphing calculator is because it has the ability to do stacked fractions. So I'm going to use stacked fractions for my benefit. Math, frac, enter. I don't think it could do brackets, so I'll just do parentheses, 1 minus parentheses, negative 1 divided by 3 parentheses. And I could have used the stacked fraction on that 1/3, I just got lazy. Raised to the 11, close up my parentheses, and on the bottom, can we all just agree that that means 1 plus 1/3?
Yeah.
There. Watch what this thing equals. No, a number that's just a little bit bigger than 3. See, 3 point, let's give it 5 decimals. 1, 2, 3, 4, 2. There we go. a number really close to 3. That's interesting. That's so insanely close to 3. Now, it's not the limit of the sequence. The limit of this sequence is... Let's see, I'm trying to remember how... I'm trying to see it in my head. The limit of the sequence does not exist because this thing oscillates. It goes positive, negative, positive, negative, positive, negatives. So the limit of the sequence does not exist. What does it mean? What a good question. Anyway, all right. You had a question for me? One of the times that the limits don't exist is if they go to one of the infinities or if they happen to oscillate. Okay. Hold on. Yes, Tommy T.
So, like, you said it was interesting.
Yeah, it is interesting.
Well, why is it?
You'll find out. Okay.
When you look up on Google, it says, like, what's the meaning of life? And it says 42. Does that have, like, actual mathematics?
No, it's from a movie.
Okay.
It's from Hitchhiker's Guide to the Galaxy. I haven't seen it either. Okay.
How do you know that? That's a good movie.
Now this, even though I'm going to cover it and I will use it a little bit here in a little while, this can get really confusing. And this is one of the times where recursive ideas are useful to us. Again, we won't use it that much in this course, but it does get used often in IB mathematics in case you were thinking about going that road. S sub n means an nth partial sum. So if I felt like listing them, S sub 1, S sub 2, S sub 3, S sub 4, by golly, I just made a sequence out of the sums. It's a sequence of partial sums. S sub 1, S sub 2, S sub 3, S sub 4, with commas in between them. But here's the thing. S sub anything is found by adding up a certain number of terms. So S sub 1 means add up the first term. Okay, what's the first term? So S sub 1 is A1. Now S sub 2 would mean add up the first 2 terms. But that's the same thing as saying S sub 1 plus the next term. S sub 3 means add up the first 3 terms. But that's the same thing as saying S sub 2 plus A sub 3. So on and so forth. So that's recursive mathematics. Neat, huh? Well, guess what? If you had listed out all of the S subs for this one, you would have gotten a very interesting answer. It's 3. So what's going on here is called an infinite series, not a finite, an infinite series, meaning we have added up an infinite number of things. Now that sequence does not converge, but guess what? Its series does. If you add up the infinite number of terms here, they add up to 3. Let me show you why. So we have here S sub infinity. That means add up all the stuff. This also means add up all the stuff. And if it goes plus dot, 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 that also means add up all the stuff. Sometimes adding up all the stuff in an infinite series heads towards an actual number. And when that sum is an actual number, we say that that series converges. Now, if it doesn't go to an actual number, if it goes to one of the 2 infinities, or if it oscillates between values, then we just say that the series diverges, just like you would have said for a sequence. So let's look at these partial sums. Notice they all end in dot, 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 meaning let's just see what happens if we add up all infinity of them. What a weird thing to say. It makes perfect sense. So this first one has asked us to find the first 5 terms in the sequence of partial sums. That means find S1 through S5. Well, S sub 1 is just the first term, so it's 0.1. That's easy. And S sub 2 means the first 2 terms need to be added. But if you add up the first 2 terms, you get 0.11. Then when you add up the first 3 terms, Well, it just extends the pattern a little bit. S sub 4 sticks another 1 on the end there, and you guessed it, S sub 5 is 0 point and then 5 ones. It would be 0 followed by a decimal, and 6 ones would be S sub 6. 7 ones. You see how this is working? Look, each time there's one more decimal place. So what does that imply? That implies that if I could find the sum of all infinite following this pattern, what would it equal? Nope. It would equal 0.1 repeating, right? Well, 0.1 repeating is 1 over 9. Yep. So you could take an infinite number of terms from this sequence and add them up, and they would add up to 1/9. Yeah? They mean the same thing. 0.1 repeating is 1/9. Hey, who's ready for a mind bomb that I will be able to explain tomorrow maybe?
Wait.
Now, some of you may already know this fact, so if you do already know it, just whatever. But here you go. 0.1 repeating is 1/9. Okay. What is 0.3 repeating? 1/3. What is 0.6 repeating? So by that logic, what is 0.9 repeating? 3/3, right? Which is 1. Guess what? 0.9 repeating equals exactly 1. They are the same number. 0.9 repeating equals 1. They are the same number.
But they don't, though.
But they do.
Let me break it down for you. They don't.
And I can prove
You
it.
see 1 in that number? I don't. I see 9s.
I'll prove it to you tomorrow probably. I don't think I'll get to it today. So you hold on to that. Go home, tell your parents, and then when they tell you that I'm wrong and you're wrong, then tomorrow after I've taught you the more stuff, you can go home and you can prove it to them. Huh?
Okay, take a guess. I think I heard that when I was like 8.
Well, I mean, it's nothing to guess. Like, there's an actual math.
No, I mean, like, isn't it because, like, if you add any number at any point, it's technically more than 1?
I don't know what. No, I don't know. I can prove it to you using the stuff in this section. Okay. What? 1/9 is 0.1 repeating.
And then that 1 equals.
1 is 0.9 repeating. Would it just be 1?
Wait, what? Can you say it again?
1 equals.
How about let me finish the notes and then I'll say it again after the video. Okay. Here we go. This is arithmetic. This is an arithmetic sequence, and we're adding up the terms. So let's see. S sub 1 is, come on, Amazon Basics. S sub 1 is 10, and well, S sub 2 is 10 plus 20, or 30, and add 30 to that, you're going to get 60, and add 40 to that, you get a hundo, and add 50 to that, you're going to get 150. So those are the first 5 partial sums in the sequence. Well, every single time the next number in the sequence, meaning the next number in the series, is going up by 10. So what does that imply about S sub infinity? S sub infinity is, well, going to infinity. So we say it diverges. S sub infinity is just getting larger and larger and larger. It'll never stop getting larger. Spoiler alert! There is no such thing as the sum of an infinite arithmetic series. They always go to one of the two infinities. Only geometrics have the opportunity to crash down to a number. You'll see. Alrighty, let's check out this last one. Okay, S sub 1 is just the first term. S sub 2 is 1 and negative 1. Then S sub 3 tacks another 1 on there, and S sub 4 subtracts that 1 again, and S sub 5 is 1, and what is going on here? It's oscillating between the values 0 and 1. Now here's the problem. Because we don't know whether or not infinity is an even number or an odd number, because, well, guess what? It's not even a number. But because we don't know if it's an even value or odd value, we don't know if this sums to 1 or sums to 0. So because of that, we simply say it diverges because it oscillates. Stop it. There we go. Diverges because it oscillates between positive 1 and 0. Yeah, do we want me to write because it? Yeah, because it oscillates.
Because oscillates. Yeah, have you ever seen an oscillator?
Not too bad, right?
Wait, so oscillating to explain it now?
No, we're not done yet. We still have more stuff to learn.
Oh my gosh, it's me again. It's me in 2 years.
That's John Lennon.
So let's talk about this sum of an infinite geometric series. You know what? Before we even do that, let me come back over here to the formula of the nth partial sum. Let's look at this formula. Now, you don't know why this formula is true. I just need you to trust that it's true for now. But once you do trust that it's true, let's talk about what happens as n gets catastrophically large. Meaning, let's see what happens towards infinity. Well, r to the infinity then has two choices. It's either going to be gigantic or it's going to become incredibly small. But under what circumstances would r to the infinity become insanely small?
Zero.
But what would make it approach 0?
A lot of zeros and then decimal and like 1 at some point.
When it diverges, no converges.
I'm asking you what property of that r, if it was a number, would allow r to the infinity if it was a fraction or a decimal. And what you two mean is a number between 0 and 1. Because technically 5 over 2 is a fraction. But what you meant when you said that was a number between 0 and 1.
Yeah.
Well, here you go. You see, if you let r to the n become very, very, very small, meaning r must have been a number between 0 and 1, which is what this says, also between 0 and negative 1. Again, that's what that says. Then 1 minus 0 is just 1, and the first set of parentheses, the one on the top of the fraction, goes away because it means nothing. Which means this is the sum of an infinite geometric series. As long as your common ratio is between negative 1 and 0 or 0 and 1, then it will add to a number. If it's anything outside of that range, it'll diverge. Cool with that? As long as r is small enough, meaning between 0 and 1 or between 0 and negative 1, that's what that says, then this is how you would add up the infinite number of terms. It's just first term divided by 1 minus r. Pretty darn cool. So these 4 examples say determine whether the series converges, and if it does converge, let's figure out what they add up to. You might notice that these sigmas, these 3 sigmas, are missing the number on the bottom and the number on the top. And well, what that implies is that it begins at 1 and never stops. That's what that implies. So not only is it infinite, it also begins at the value of 1. Because if it begins anywhere else, we have to actually say that. Okay? It's one of those things like, you know how you don't have to put the index on a square root, but we all know it's a 2? It's like that. Because most sigmas in mathematics go from 1 to infinity. So we said, well, since that's the most common thing, how about we all just get lazy and stop writing it? And that's what happens here. So what are we looking at? I'll tell you what we're looking at. We're looking at legitimately the general term of a geometric sequence, where r is 0.75. Well, the absolute value of that just does so happen to be less than 1. Wait a second. Wait a second. It looks like an exponential equation. What do we call exponential equations whose exponential base is between 0 and 1? Oh, decay. Oh, almost like decay graphs crash into values. How about that? No, they crash into their asymptotes. But these, it's like if you were to add up all the y values, they also crash into something. Interesting how that stuff's related, huh?
Is that right?
Yeah.
Oh,
Yeah. That's exactly right.
is the ball a mathematical symbol?
No, a ball is a mathematical construct that has rules. This is a scribble.
Okay.
There's a ball in math.
Yes, it's a part of abstract algebra.
Ball.
You're welcome to look it up. Anyway,
It's just a black hole.
well, since we know this converges, because the absolute value of r is less than 1, let's go ahead and see what it adds up to. S sub infinity is the first term. Well, we find the first term by plugging in k equals 1. So we plug in k equals 1. 0.75 to the 0 is just 1. And 1 times 3 is 3. And 1 minus 0.75, it's this. It's 1 minus r. I'm just filling out the 1 minus r formula.
How'd you get 3?
Because I plugged in 1 right here to find the first term. This is a sub 1. So you get 0.75 to the 0, which is 1, times 3.
Oh, okay.
So this would sum to the number 12. Ta-da! Pretty neat too, huh? Now this one we need to be a little more. Yes. Yes. If you're trying to find the first term, you plug in 1. So like this one, you might notice that this one is not written in the general form of a geometric sequence, but that doesn't change the fact that you can still see what its common ratio is. Its common ratio is -4/5. So the absolute value of that is +4/5, which is less than 1. So this one will also converge. But to what is the question? I can tell you that this time a sub 1 is found again by plugging in n equals 1. It's not the value sitting in front of the common ratio. Remember, in front of the common ratio is 1. But if you plug in n equals 1, what you get is that a sub 1 is -4/5. Because you plug in n equals 1 to find your first term, which is what we did up there also. And 1 minus -4/5. So -0.8 divided by 1.8 is -0.4 repeating, or -4/9.
So it could be either of those on the test too?
Yeah, but I'll probably use fractions because that's easier for me to deal with than the overbar. The overbar is not always very easy. Yes? Shh. So the top number is a sub 1, right? That's when n equals 1, right? No, I plugged in a 1 right here. -4/5 to the 1. This one's different because it says -1 in the exponent. So when you plug in 1, you get 0 as an exponent. That's what makes them different. So you just have to be careful, okay? Anything to the 0 power equals 1, yeah. Let's check out part C. Pi is a number. Yeah. Yeah, I am sure. And it's somewhere around 3.14. So when you cut it in half, you get somewhere around 1.57-ish. That's bigger than 1. Diverges. So we cannot find an infinite sum there because it diverges. And lastly, this one is a geometric sequence written series form. So it's a geometric series. I can see that a sub 1 is 1, because it's the first term. And I'm hoping that you can see what r is.
Divide by 2.
Well, it's 1/2. We're multiplying by 1/2, which is the same as divide by 2, but you want to stick with multiplication. So this common ratio is 1/2. Well, guess what? That's less than 1, so it converges. Let's see where it converges to. S sub infinity is first term divided by 1 minus 1/2. Well, 1 minus 1/2 is 1/2. And 1 divided by 1/2 is 2. Woo! Look at that. Interesting. We're going to stop it there because that's where I stopped it with first period.